Hello everyone, welcome to my channel Chem Insider. So in today's video we'll be discussing about the last topics related to the chemical bonding chapter of class 11. So in the previous video we learnt about how to draw or how to learn about the bonding present in homonuclear diatomic molecules such as hydrogen, helium, lithium, beryllium and carbon. So now we'll be discussing about the last one of the homonuclear diatomic molecules bonding, and then we'll discuss about the hydrogen bonding. Now, when you have to consider for the bonding in homonuclear diatomic molecule of oxygen. So if you consider for the homonuclear diatomic molecule of oxygen molecule has two atoms of oxygen, and therefore the atomic electronic configuration of oxygen atom is 1s2, 2s2, 2p4. So clearly it carries 8 electrons in its atomic state. Okay, oxygen atom has 8 electrons, so that implies that it will be having 16 electrons in its molecular state. Now when you are considering for the number of electrons present to draw the energy level diagram of a molecule, we need to consider for the electrons which are present less than 14 or those molecules which have electrons more than 14, right? So now here oxygen molecule clearly has electrons more than 14. Therefore, if you have to write the electronic configuration of the molecular oxygen, electronic configuration of oxygen molecule, it will start as sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. So this is all you know that. Now for the sigma of p orbitals. So now what happens is we'll come across sigma 2pz 2 first, then we come across pi 2px 2, which is equals to energy of pi 2py. So both of them carry 2 electrons each. Now if we calculate the total number of electrons here, so it is 8 plus 6, 14 electrons. So we are left with just 2 electrons. So the next higher energy orbit for energy level diagram of molecules having more than 14 electrons, we come across the pi star orbital, pi star 2px, which is equals to pi star 2py with the same energy. Now what we know is, according to Hund's rule of maximum multiplicity, so any atom or electron should acquire to an orbital in such a way that first it should complete the number of electrons in the particular orbit which has same energy. Then only it can enter the higher energy orbit. So therefore, if we consider 2px and 2py, so both these two have same energy further, and they cannot be supposed to pair. The 2 electrons which is left will not be supposed to pair up until unless the orbitals with the same energy, degenerate orbitals with same energy, are singly occupied. Therefore, the 2 electrons in these oxygen molecules reaches 1 in each of the pi star 2px and pi star 2py orbital. Okay, so therefore we can clearly say that since there is a presence of 1 electron each in 2px, pi star 2px and pi star 2py molecular orbital, so there will be 2 unpaired electrons present. Okay, so clearly oxygen molecule has 2 unpaired electrons present, because out of the last 2 electrons, one of the electron will re-enter the pi star 2px orbital and the other electron enters the pi star 2py orbital. It will not get paired up because to follow certain rules. So now if you have to discuss about the bond order, so bond order of oxygen molecule is 1/2 into Nb minus Na, right? So the number of bonding electron in this particular oxygen molecule is 2, 4, 6, 8, 10. So total number of bonding electrons is 10. Number of anti-bonding electrons 2, 4, 5 and 6. So that gives us 4/2. Therefore the bond order is 2. So bond order of oxygen molecule is 2. Bond length of this molecule is almost similar to the bond length of carbon molecule. So the carbon molecule bond length was 134 picometer. but the oxygen molecule's bond length is around 128 picometer. So that is because it is of a bigger size. So bond length will be a bit closer to one another. Okay, and the magnetic property, it is paramagnetic in nature. So the only reason why we consider molecular orbital theory for consideration is it explains the theoretical and both experimental magnetic property of molecules using unpaired electrons. So oxygen molecule, which was found to be paramagnetic in theoretical wise and experimental wise, holds good according to the molecular orbital theory. Okay, so this is about the bonding in homonuclear diatomic oxygen molecule. So we can also discuss about the diatomic molecules of second group period or third group period also. It almost quite similar to these, which have more than 16 electrons. Next, we will discuss about the last topic of this particular chapter, that is hydrogen bonding. So now, what is hydrogen bonding? We have discussed about covalent bonding, coordinate bonding, and also about the ionic bonding. Now, for hydrogen bonding or hydrogen bonds especially. So what is an hydrogen bond? So hydrogen bond comes across in those compounds which have at least one hydrogen and an electronegative element. So whenever you consider hydrogen being attached to any of the strongest electronegative elements, those are nitrogen, oxygen and fluorine. If hydrogen is attached to one of the nitrogen, oxygen or fluorine, which are called the strongest electronegative element, these are the most electronegative elements. If hydrogen is present attached to these electronegative elements in a molecule, then we can say that the given particular molecule has hydrogen bonding in it. Okay, so how is this hydrogen bonding formed? Let us consider for an example of hydrogen fluoride molecule. If you consider hydrogen fluoride molecule, so clearly out of hydrogen and fluorine, fluorine is more electronegative. Therefore, if you write the Lewis structure of hydrogen and fluorine, so it has two electrons in this way, which is formed because of sharing of a covalent bond. So now, the two electrons which was supposed to be present at the center from one another is completely moved towards the fluorine atom. That is because fluorine atom is more electronegative. Since the electrons are completely dragged towards the fluorine atom, hydrogen carries a slight positive charge as it is more electropositive when compared to fluorine. So therefore, it carries a delta plus charge, which is called the partial positive charge. Similarly, fluorine, which has gained an electron from hydrogen, carries partial negative charge denoted as delta minus. So because of this delta plus formation of charge, that is a partial positive charge formed on the hydrogen atom, it reacts with any of the atoms or electronegative elements which have lone pair of electrons or which are said to be electronegative elements. So if you consider this as the hydrogen fluoride atom, if you consider for a hydrogen fluoride molecule, there will be more hydrogen fluorides, right? So there will be more hydrogen fluorides present. So what happens is the fluorine, which is more electronegative, might attack the hydrogen atom of the other molecule. This hydrogen will be attacked by this fluorine. This fluorine might attack this hydrogen. So what happens is, because of the higher electropositive nature of hydrogen and the very high electronegative nature of fluorine, there will be a small interaction between fluorine and hydrogen of two different atoms, which is called as hydrogen bonding, and it is denoted as in a dotted line of 3. Okay, so the 3 dotted lines indicates that there is hydrogen bonding formed between the molecules of the given compound. Okay, so this is nothing but a hydrogen bonding. So why is this hydrogen bonding formed? What is the criteria for this hydrogen bonding to be formed? Is if you come across a hydrogen fluoride molecule or any of the molecule which has an electronegative element, then the electron present which is shared by forming a bond, covalent bond, the two electrons which is forming a covalent bond will be dragged towards the fluorine atom, as the fluorine or the electronegative atom of nitrogen or oxygen is more electronegative, which induces a partial positive charge on hydrogen and a partial negative charge on fluorine. Since hydrogen carries a partial positive electropositive charge, it creates an electrostatic force of attraction between these two molecules, hydrogen and fluoride atoms. Therefore, the fluorine of the other molecule might react or attack the proton, that is the H plus ion, formed because of the delta partial positive charge. So the delta negative charge of the fluorine might attack the delta positive charge of hydrogen, creating a certain type of interaction which is called the hydrogen bonding. Remember, this hydrogen bonding is weaker bond when compared to covalent bond. Weaker than covalent bond. And further, what we have to know is, if you consider certain compound which have hydrogen bond, they will be having higher boiling point and melting point when compared to those compounds of same molecular mass with no hydrogen bonding. If you consider two carbon compounds of haloalkanes, so what you can say is alcohols and hydrocarbons. Alcohols have intermolecular hydrogen bonding, whereas hydrocarbons do not have any hydrogen bonding involved in it. Therefore, hydrocarbons have less boiling point and melting point. Alcohols have a very high boiling and melting points. So what we can clearly say is, the presence of hydrogen bonding can clearly influence certain changes in physical and chemical properties. Okay, so this is about the hydrogen bonding. There are two types of hydrogen bonding: intermolecular hydrogen bonding and intramolecular hydrogen bonding. Now let us discuss about inter and intramolecular hydrogen bonding. First is intermolecular hydrogen bonding. So, intermolecular hydrogen bonding is a type of hydrogen bond formed between two different atoms, so two atoms of different molecules. So these different molecules might be the different molecules of same compound, or might be different molecules of different compound. Like for example, if you consider hydrogen fluoride, so it has a covalent bond between hydrogen and fluorine. So these two might interact with one more molecule of hydrogen fluoride, which carries a delta positive negative charge, delta positive charge. So if this fluorine reacts with the hydrogen of the other molecule of HF, if one electronegative element of molecule reacts with electropositive element of the other molecule, then that particular type of interaction is called intermolecular hydrogen bonding. Here, it might be because of two HFs, or it might be because of different molecules also, like when you treat HF with alcohol, CH3OH. So this oxygen might react with this hydrogen, this chlorine might interact with this hydrogen. Okay. If hydrogen bonding exists between two different molecules, then that particular hydrogen bonding is called intermolecular hydrogen bonding. So intermolecular hydrogen bonding can be defined as the hydrogen bonding initiated between atoms of two different molecules. One, it should be an electronegative atom, and the other, it should be a hydrogen atom attached to one more electronegative atom. Okay. Here, if you consider for this CH3 molecule, even though the hydrogen is attached to electronegative carbon, carbon is not said to be a strong electronegative. Therefore, these hydrogen will not interact with any of the electronegative elements to form hydrogen bonding. Okay. So the necessary condition for hydrogen bonding to form is the hydrogen should be attached to an electronegative element, and it should react with the different electronegative element or same electronegative element of different compounds. Okay. So fluorine, oxygen and nitrogen only shows electronegative element property, in a higher extent. Therefore, they show hydrogen bonding with those of the hydrogen attached to different electronegative elements. If the hydrogen bonding is formed between two different molecules of compounds, then those are called intermolecular hydrogen bonding. Example, hydrogen bonding which is formed between two molecules of HF, hydrogen fluorides, or a molecule of hydrogen fluoride with methanol. Okay, so these are the examples. Next is intramolecular hydrogen bonding. So intramolecular hydrogen bonding is a type of case where we observe hydrogen bonding happening in the same molecule itself. Like for example, if you consider orthonitrophenol, so the benzene ring which has a nitrogen and oxygen group and an OH group. So what happens here is the oxygen present here might interact with this hydrogen. Okay, the oxygen present here might interact with the hydrogen present on the different atom of the same molecule. Okay, so this is completely a single molecule. So here hydrogen bonding is arised between oxygen of the nitro group and hydrogen of the hydroxyl group attached to the same benzene ring. So this type of bonding is called intramolecular hydrogen bonding. So this is called intramolecular hydrogen bonding. So if the hydrogen bonding arises between the electronegative atom and a hydrogen atom of the same molecule, then those type of hydrogen bonding are called intramolecular hydrogen bonding. Okay, so this is about the hydrogen bonding topics. I hope you have understood this hydrogen bonding, that is of intermolecular and intramolecular. So this is all about for this chapter. I hope you understood all the concepts which I explained. If you still have any doubts regarding the topics of any of this particular chapter, please do subscribe to my channel and comment down those doubts in the description box or comment box, or you can mail those doubts to me which I have provided my mail ID in my description box. Thank you for watching.